All right, we're given problem number 15. In problem 15, we're given that there is an object 25 centimeters to the left of lens 1. The distance between the two lenses is 50 centimeters, and there is a given image, which is our final image, that is 20 centimeters to the right of lens 2. Lens 2 is also said to be a converging lens, with focal points that are 5 centimeters on either side of the lens. The problem asks for us to find the distance of f1, the focal points for lens 1, and tell whether lens 1 is converging or diverging. So we started over here at the image and we worked backwards. We know that if this is a converging lens, the rays hitting the top of the image need to come back and bend down away towards the intermediate image, being that it's converging. And that gave us an intermediate image right in here. Then we took the object and we drew the principal rays from here, and we know that the principal rays from the object have to come to the point of the intermediate image. Therefore, the top ray has to bend downwards through the right focal point, the bottom ray has to go through the left focal point, the other one going through the origin of the lens, and they all connect at the intermediate image, meaning lens 1 is a converging lens. And the math to find the exact distance of the focal points will be done after this.
Alright, so the first calculation we have to do is calculate P2. And so using this equation, we plug in a few numbers from the diagram. First, we're going to plug in Q2. We were given that the image is 20 centimeters to the right of lens 2, so we plug in 20 here. And we were given that the focal point of lens 2 was 5 centimeters, so we plug 5 into F2 here. And going through the math, we get P2 is equal to 20 over 3 centimeters. And that indicates this distance right here from lens 2. And we will use this to calculate F1 in the next calculation.
Okay, so we're going to continue working backwards, but first we need to find what Q1 is. And Q1 is the distance between the two lenses, which was given as 50 centimeters minus P2, which we just found. So it'd be 50 minus 20 over 3, and when we do the math, Q1 ends up being 130 over 3 centimeters. And then we plug this into the thin lens equation of lens number 1 to find F1. And we are already given P1, which is 25 centimeters. So then we plug in the reciprocal, we do the math, and we end up with 15.9 centimeters. And this focal length is positive, which indicates the lens is converging.